Alright, so I think I'm recording here. Now we're going to look at solving these exponential equations. Um, Later in the skill packet, we solve exponential equations where we're going to have to use a function called the log function, logarithmic function, which is the inverse of an exponential function, um, because we'll need the properties of logarithms to isolate our variable. But here we won't need to do that. We'll be able to use our properties of exponents, and I think you'll be okay with solving these, provided that you know your properties of exponents from Algebra 1 and Algebra 2. So one property that we're going to use about exponential functions is that they're a one-to-one function. So if the number is the same and the base is the same, then the exponents must be the same. So that's what we're going to try to do, is rewrite um, all of these numbers with the same base. So when I look at the number 32, I have to think of it of some base raised to a power that equals 32, and with playing around with it and just um, experimenting with arithmetic, you'll see that 32 is 2 raised to the fifth power. Now that 32 has an exponent of x plus 1, so 2 to the fifth will have an exponent of x plus 1. And 64, well, you get 64 by doubling 32, so that's 6 factors of 2, and 2 to the 6th. So when you have a power raised to a power, you multiply these exponents. So I have 2 to the 6th power is equal to 2 raised to the 5x plus 5, because I multiply this binomial times 5. Multiplication distributes over that addition, and I get 5x plus 5. So here was what I was talking about. Since the exponential function is a one-to-one function, and the left-hand side is the number 64, well, 64 equals 64. The right-hand side is also 64. So if the numbers are the same and the bases are the same, the exponents have to be the same. So this 5x plus 5 has to represent the number 6. Now, you know how to solve this equation to step by step get the x by itself. On the right hand side, there are two terms. We want the term that has our variable by itself. So the inverse operation of adding 5 is to subtract 5. If we subtract 5 from both sides of the equation, or if we think of it as moving this term to the other side, when a term changes sides, it changes sign. So on the left-hand side, we have 6 minus 5. And on the right-hand side, with 5 minus 5 being 0, we typically don't write plus 0. So we're trying to get this x by itself. Right now it's being multiplied by 5. There's two factors on the right-hand side. We want to get the factor x by itself, and so the inverse of multiplication is division. So we divide each side by the number 5, and 5 divided by 5 is just 1, and 6 minus 5 is 1, and so then we divide that by 5, and that's our answer, that x is equal to 1/5. We do not have to worry about extraneous solutions for exponential functions, because exponential functions have a domain of all real numbers. This x is not restricted. It could be anything, and we claim for this equation to be a true statement that x must be 1/5. So hey, I hope that helps, and I'll talk to you later. Bye.